Yes. Deborah, Fadil, is it audible to all of you? Mir Hussain. Okay.
Yes, ma'am.
All right. So yes, till here we had completed the last equation. We had derived all the values of it, right? Magnetic field also we had written, electric field also we had written. So definition of EM waves also we had completed, electromagnetic spectrum it was there. So one table I'll share on WhatsApp. Just wait, let me know when you'll receive it. I've shared a table on WhatsApp. Just confirm once you've received it. Both the groups I have shared it, girls as well. Just update me about the same. Okay. Regarding the order you're asking, see, start from this. One pattern you have to follow. So when we are talking about these are the gamma rays. These are the X-rays which are present. Here we have the ultraviolet. This is the visible. This one. This is the infrared. Here we have the microwaves. And the last we have the radio waves. So when we are talking about the order of frequency and wavelength, one is having the highest one is having the least one. So when you're talking about the gamma rays, remember frequency increases in this order. So radio waves will be having the least amount of frequency, gamma rays will be having the highest amount of frequency. But this is exactly the reciprocal case when we are talking about the wavelengths. So when we are talking about the wavelengths, this is increasing in this order. It means radio waves will be having the highest one and the gamma rays will be having the least one. Even if you look at the table that I've shared with all of you will see the frequencies values are mentioned. Just go by the powers of 10. Don't remember the entire value. Like if you start with radio waves, it is 10 to the power 4 to 10 to the power 8. Then when we're talking about the gamma rays, 10 to the power 18 to 10 to the power 22. Similarly, if you see the order of the wavelength, radio waves, these are having more than 0.1 meters. All right, 0.1 meters. And when we're talking about the gamma rays, this is less than 10 to the power 3 nanometers. What is meant by nanometer? Is 10 to the power minus 9 meters. So 1 nanometer is equal to 10 to the power minus 9 meters. So these have the certain applications which are already mentioned in the last column. You can read through it. Some properties were left to be discussed in the last class, right? Let's start with those first. You can copy down it later. I'll give you time for this, but first let us start with the properties. So in that table, the properties are also mentioned, but these are mentioned regarding specific waves. If suppose I talk about infrared, so the frequency, wavelength, every information about infrared is mentioned, but in general about the entire electromagnetic spectrum, that is omitted. So as let me show you the diagram which we had discussed on the last class, this one. See, here you can see through the graph, electric field is present along the y-axis. You can see magnetic field is present along the x-axis, and this is along the direction of propagation of wave. So what did I tell? All these are present on the different respective axes. So if they are present on their axis, all of them will be making an angle of 90 degree to each other. Correct. So if angle of 90 degree is made, direction of propagation will also be perpendicular. Electric field and magnetic field were already perpendicular. So that becomes the first property. This we had seen also. Coming to your magnetism, which we had discussed in chapter 4, magnetic effects of electric current. There we had seen magnetic Lorentz formula, QVB. And from your electrostatics, so this was the formula of magnetic force. you had the formula of electric force as well. That was QE. So this is magnetic force, this is electric force. When both the forces are equated, charge will be cancelled. From here, value of velocity is equal to the ratio of electric field to the magnetic field. This is the ratio. So this is another property, as in if you have the electric field's peak value as well as the magnetic field's peak value, and when you take their ratio, you get the speed of light. So what is the speed of light? 3 into 10 to the power 8 meter per second. So if the peak values from both the waves are extracted, either from the electric fields one or from the magnetic fields one, their ratio will give you the speed of light. But in general, if we are not talking about the speed of light, you will get a velocity, whichever medium it is kept. So this formula is useful because you will be getting numericals on this formula also. And we had discussed this also. You had a topic cyclotron, which is now deleted in your syllabus. Earlier it was included. So there also this was there. So that's why we didn't discuss it. So over here we are discussing. Next is speed of electromagnetic waves in vacuum. When we're talking about the speed of electromagnetic waves in vacuum. So one formula, we had discussed the constant that was coming. The force in different medium, the forces were governed by epsilon naught. That was the permittivity of different media. And when we were talking about the same thing in electrostatics, in magnetostatics, we were talking about the permeability. So basically, speed of light is 1 by under root epsilon naught into mu naught. So if you substitute all the values, mu naught's value is also specified. 4 pi into 10 to the power minus 7. Let's put the values and check. If you put 4, pi is 3.14. Then 10 to the power minus 7. Permittivity is value 8.85 into 10 to the power minus 12. When you substitute all the values, under root, reciprocate it, this value will be exactly equal to 3 into 10 to the power 8 meter per second. What is 3 into 10 to the power 8 meter per second? The speed of light. So you are getting the speed of light in the vacuum. When you are talking about the electromagnetic wave in a particular medium, so I had told you for different medium, you have the concept of relative permeability and relative permittivity. So both of these will be applied over here. So when we are talking about the velocities, instead of directly just writing permeability, we'll be having permeability multiplied to the relative permeability. That is mu naught multiplied to mu r. Similarly, when we are talking about the permittivity, from here, only epsilon naught will not be included. We'll be having epsilon r, that is the relative permeability. This will be included. But this is in those cases where you don't have vacuum as the medium. Air or free space is not included. For any other type of material, you will be using this formula. This one is applicable just for vacuum. Yes, correct. Fine. So see, how will you relate both of these? One is this, the third point. This is the third point. This is the fourth one. See, there's a relation between them. You can easily extract. I'm writing it. Wait. V is equal to 1 by mu epsilon. So this is mu naught mu r. This is epsilon naught epsilon r. When we'll expand this, epsilon naught mu naught epsilon r mu r. So from here, if you rearrange these terms, look, if we have mu naught over here, epsilon naught over here. So from here, if we are extracting this portion, so this is directly giving us 1 by under root epsilon naught mu naught. This was exactly the speed of light. So now we have a relation between the speed in any medium and the speed of light, which we had seen in the third point. So velocity in any medium when you're talking about is c divided by under root epsilon r mu r. So from here you have the relation c, that is the speed of light. This is the speed of light whose value we'll be writing 3 into 10 to the power 8 meter per second. Refractive index, optical phenomena. This I'll discuss later. First, note it down till here. This also you have to write. Electromagnetic spectrum. Write it from here. Yes. So fifth and sixth point, these we have covered already in the ray optics unit. So refractive index one and optical phenomena. So both are applied over here. So both are applicable, both are applied over here. So this I'm not discussing, coming directly to energy density. So energy density is energy per unit volume. So we'll be talking in terms of electrical energy and magnetic energy. This we have already discussed. Electrical energy in chapter 2, when we were talking about capacitors, that time we had discussed. Magnetic energy in chapter 4, we have already covered. So here you have the formula half E square into epsilon naught. And for magnetic energy, you have half V square by mu naught. So when we are talking about the total energy density, so we'll combine both of these. This will be added to this. So when we are talking about here, this, look, this is half E square epsilon naught plus half B square by mu naught. There was a relation in alternating current we had seen regarding the peak value and the RMS value. See, it's written over here, look. ERMS will be E naught by root 2. And when we are talking about B naught, BRMS, it is V naught by root 2. So here as well, when we are talking about the total energy half, this energy which is specified over here, this is RMS. So this is either I can write it in this manner or this, both are the same. So into epsilon naught plus half, this is BRMS square by mu naught. Now, if I have the peak values, because in the wave equation, we had seen the first value of all before the sine theta, that component came, it was always the peak value one, right? So into RMS, we have to convert the RMS value into the peak value. So if I'll square it, why there is a need to square? Because here in the formula, we are already getting a square. And since we are converting RMS into peak value, we'll have to square this up. Look here. This is already squared up. This isn't. So we are squaring this also in order to make this equal to this, so that we can substitute it in this formula. So total energy will be half is already there. If I am putting the value of ERMS square, so this will be E naught square by 2, and epsilon naught was already here, plus half. This is V naught square by 2 and 1 by mu naught. Because see, epsilon naught was getting multiplied, but in magnetics we had mu naught getting divided. Right. So when finally you will have the difference between DC and AC will arise by this digit, that is 2. This will be half of it. Because here we are getting 1 by 4. The rest of the part is same. This is a peak value of electric field into epsilon naught plus 1 by 4 B naught square by mu naught. So this is the formula. This derivation is included in your syllabus. This derivation can come. No, not a 5-marker. Your 3-marker questions maximum. Either in 2-marker questions or your 3-marker question. It's not a 5-marker question. This one. But yes, formula based questions can be there, but derivations have also come in your previous year's paper. There's a relation between the energy and the speed of light which is occurring, and momentum. Momentum is the product of mass and velocity, which we had studied earlier. Here, in terms of waves, when we are talking about EM waves, this is the ratio of energy to the speed of light. This is the energy by the speed of light. Now, look, when we are calculating momentum, here we have to apply the rules the way we were applying in terms of vectors. You had taken one direction as positive, the opposite one was taken as negative. So here if the wave is coming, electromagnetic wave is coming on the absorbing surface. So suppose I have taken this direction as positive. So this momentum will be positive, that is P. When I'll be calculating the net momentum, it's P1 minus P2. So this P by the sign convention, it's already positive. right? Because this is in the direction that we have ourselves chosen it as positive. But when it will be reflecting from a reflecting surface, when it will be reflecting, when the reflected ray is moving in the opposite direction, so now it is in the opposite direction to our chosen sign convention. So if downwards I had taken positive, this is upwards. If right you're taking positive, left will be negative. So upwards, this will be negative. So that's why this momentum, even though the magnitude is same, direction is opposite here. So we'll be having the negative sign. So this is minus P. Now, when we are calculating the net momentum, P1 minus P2, P1 is P from here minus P2. P2 is already minus. So see, minus minus plus. So this is 2P. So remember, when it will be reflected, it won't be cancelled because of the sign conventions. This will be 2P by T. So this is the formula of force. This is the momentum. And this is the time. So it will be doubled in case of the waves. This is similar to the velocity sign convention we were choosing in relative velocity in 1D. If we are talking about this velocity, suppose this is propagating in this direction. Let's say 5 meter per second. So if V2 is there, this value is 3 meter per second. If I'm choosing this as positive, this has to be negative. So rather than simply, because they were already in the opposite direction, they were already making 180-degree angle, we could have directly subtracted them. But see, once you are putting the sign convention, minus, minus, one more minus is coming. So instead of getting subtracted, they are getting added. That is the same thing that is occurring over here, twice the momentum which is occurring. This is the last property, intensity. Intensity's definition, you can say, or simply the formula is energy per unit area per unit time. So energy per unit time, this is already power. So intensity's formula will be power per unit area. This is intensity is equal to power per unit area. Now, when we are talking about its SI unit, if you write it from here, this is joules, this is meter square, this is time. But when we're writing from here, directly you can write watt per meter square. One question also I'll discuss. Do one thing, first write it till here, then the question I'll discuss straight away. Two questions I have to discuss first before we start with the rest of the properties. One regarding the wave we'll discuss. Then we are left with Maxwell's displacement current. Write it from here, fifth point. Fourth, you all have written. If anyone has not written, just update me in the chat column. I'll scroll up. Yes, from the fifth one. Yes. So we are left with Maxwell displacement current and these two.